Hello, Maurits here, and welcome to yet another video on integration by substitution. In this case, we will look at this integral, the integral from 2 to 3 of ln x over x dx. And as you can see, compared to previously, this is an integral where we also have a lower and upper bound for our integral. So first we can see that this can be written as the integral from 2 to 3 of ln of x times 1 over x dx. And the derivative of ln x is 1 over x, and that is the key thing here, right? We can take the derivative of this first part and get the derivative of this part and get this part. So that's why we will choose ln x as our variable. So we say u equals to ln of x. That means that du dx equals to 1 over x. Multiply the dx up, and we have that du equals to 1 over x dx. And now we essentially have everything we need for the substitution. We will look at how to work with the upper and lower bounds, 2 and 3. There's two ways to go about here, but we will start with one way that I think is usually the easier way, and then we'll look at how it's usually done. So first thing we do here is we'll say our integral will now be integral from 2 to 3, but now x will go to 2 to 3. So I indicate that by writing x equals to 2 to 3 of our integral, and ln x was u, and 1 over x dx is du. Why I wrote x equals is because I want to indicate that it's not the variable we integrate with respect to that gives us the bounds. It's some other variable. This thing is very, very easy to integrate. So we get u square over 2 from x equals to 2 to 3. And now we can put back our ln x. So that will give us, and I will write a half first, of ln of x squared from x. And now I don't need to write from x by right, because now the variable is x, so from 2 to 3. And that will give us 1/2 ln of 3 squared minus 1/2 ln of 2 squared. And technically speaking, we are done now, but we could make this look a little bit nice, and we can also manipulate this value a little bit. So first we have a common factor of 1/2 ln of 3 square minus ln of 2 square. Oh, we have a difference of 2 squares, right? Because we have this rule, of course, that a square minus b square equals to a plus b times a minus b. So a could here be ln 3 and b could be ln 2. So this could be written as 1/2 of ln of 3 plus ln of 2 times ln of 3 minus ln of 2. And as I said, technically speaking, we already have the answer here, but in an exam, for example, people could ask about writing this as a product. And we don't have it as a product right now, so we need to fix, so this would be a product. So you could say, write the answer as a product of 2 logarithms or something like that. Okay, then we have a few logarithm rules that is very useful here, right? Because you have log of a times b log a plus log b, and log a divided by b log a minus log b. These two rules we can use here. This would be a half ln 3 plus ln 2, that will be ln of 3 times 2, so that will be ln of 6 times ln of 3 minus ln 2, that will be ln of 3 halves. And if the question was to write this as product of two logarithms, we need to get the half into one of the logarithms, and we can use the rule that log of a to the power of b is b log a, right? And we can do the opposite, we can move this half into this, and 6 to the power half is the same as square root of a half, so we will end up with ln of square root of 6 times ln of 3 halves. So now we have the result as a product of two logarithms. So that is one way to do it. But as I said, the very first thing, if the question was just find an answer, then this is already an answer. But if the question is find it as a product of two logarithms, then the answer we have further down is our answer. So what is the other method to do this? What we will do here at this step, we will add that we also apply the substitution to the upper and lower bounds. So we say when x equals to 2, then u would be ln of 2. When x equals to 3, then u would be ln of 3. Then we can use this at this stage here and turn our integral to the integral of u du from ln of 2 to ln of 3, which gives us u square over 2 from ln of 2 to ln of 3, right? And then we plug in our logarithms, so that will turn into ln of 3 square over 2 minus ln of 2 square over 2. And then we can proceed as before. The only difference is the question is when we do this change. Either we can do that already here at this stage, and then we proceed in that way, or we replace back our variable like we did over here, and then we get the same thing. Usually in books, this is the way they show, but I personally find this way I showed initially to be slightly easier. So the question is also, is this calculation actually correct? Let's try this. We take our calculator, depending on the model, but I will go in here to this emulation of a Casio calculator. In this one, option, calc, the integral of ln of x divided by x from 2 to 3 end bracket, and get this answer. Is that the answer we actually got? Let's try here. We can actually go to the final thing and say ln of square root of 6 times ln of 3 halves. And we got the same thing. So this seems to be correct. So I hope this helped a bit. Thank you.